What if I told you that the most expensive failures in AI systems aren't caused by bad models, they're caused by poorly designed tools? Your agent could have perfect reasoning, flawless memory, bulletproof security, and still delete production data because the tool description was ambiguous. Today, we're diving into Skill 8, Tool Engineering, the discipline that separates dangerous agents from truly capable ones. This is where your agents learn to actually do things in the world. Your agent has access to 500 APIs. It just used the wrong one and deleted production data. Not because the agent is stupid, it's actually quite capable. The failure happened because the tool definition was ambiguous. The delete customer tool and the archive customer tool had nearly identical descriptions. The agent made a reasonable choice based on the information it had. The wrong choice. Welcome to tool engineering, the discipline that separates dangerous agents from capable ones. Here's what most teams get wrong. They treat tools as technical APIs. Define the function, expose the endpoint, hand it to the agent. But tools aren't just APIs. They're the user interface through which agents interact with the world. And just like a confusing user interface causes human users to make mistakes, a confusing tool interface causes agents to make mistakes. The difference? Agent mistakes happen at machine speed, at scale, with real consequences. Consider this real scenario from a financial services firm. Their agent had tools for transfer funds and schedule transfer. The descriptions differed by only a few words. In testing, everything worked fine. In production, the agent occasionally chose schedule transfer when users wanted immediate transfers, and vice versa. Money moved at the wrong times. Customers complained. Trust eroded. The fix wasn't better AI. It was better tool definitions. This is Skill 8 in the framework of 9 essential skills: semantic capability and tool engineering. Tools are how agents extend beyond language generation into real-world action. The quality of your tools is a primary determinant of agent performance. This skill addresses the art and science of creating tools that are discoverable. Agents can find them. Understandable. Agents know when and how to use them, and safe. Agents can use them without causing harm. Modern LLMs support function calling, also called tool use. The model outputs a structured request to invoke a function with specific parameters. OpenAI, Anthropic, and Google all support this pattern, each with slightly different protocols. But the core concept is the same. You define a tool with a schema, the agent decides when to call it, and your code executes the function with the provided parameters. Every tool must have a precise schema defining its inputs, outputs, and behavior. Typically defined using JSON schema or OpenAPI. The schema specifies the function name, description, parameters with types and constraints, and return value. Ambiguous or incomplete schemas lead to agent errors. This isn't optional documentation. It's the contract between your code and the AI. The description field is where most tools fail. A good tool description answers 4 questions. What does this tool do? When should the agent use it? What do the inputs mean, and what format are they? What will the tool return? Most developers answer only the first question. The result is agents that know what a tool does, but not when to use it, leading to wrong tool selection. Here's a well-designed tool description. Get weather retrieves current weather conditions for a specified location. Use this when the user asks about current weather, temperature, or conditions. Input location is a string, city name or city, country format. For example, Paris, France. Unit is Celsius or Fahrenheit, defaulting to Celsius. Output is a JSON object with temperature, conditions, humidity, and wind speed. Limitations: only provides current weather, not forecasts. Notice how this answers all 4 questions. Error handling separates amateur tools from professional ones. A tool that returns a cryptic error code or stack trace is useless to an agent. Error responses should be structured JSON, include a human-readable message, an error code, and most importantly, guidance on how to fix the problem. Missing required parameter location. Please provide a city name. Now the agent can self-correct instead of failing repeatedly. In large ecosystems, you can't hard-code all tools into the agent's context. A financial services firm with 500 tools can't load all their schemas into every prompt. It would exhaust the context window and confuse the agent with irrelevant options. The solution is dynamic tool discovery. Agents search for and retrieve tools as needed, based on the current task. A tool registry is a searchable catalog of available tools, indexed by capability and domain. It's a database containing tool metadata: name, description, category, tags, version, schema. Agents query the registry to find tools that match their current needs. Think of it like a search engine for capabilities. The agent describes what it needs, and the registry returns relevant tools. Semantic search makes tool discovery intuitive. Using embedding-based search, agents query the registry with natural language. Tool descriptions are converted into vectors using an embedding model. At query time, the agent's request is also embedded, and similarity search finds the most relevant tools. This handles synonyms, paraphrasing, and conceptual matches, not just keyword matching. Tool composition enables complex workflows. Advanced agents chain multiple tools together, using the output of one tool as the input to another. Search documents, then extract entities, then look up entity information. For this to work, tools must have composable interfaces, standardized input and output formats, typically JSON. Design your tools with composition in mind from the start. Tool descriptions are the user interface for agents. Just as human users struggle with confusing interfaces, agents struggle with confusing tool descriptions. The field of tool UX design applies usability principles to make tools that agents can understand and use correctly. This isn't about making tools simpler. It's about making them clearer. Semantic altitude is the level of abstraction in a tool description. Too specific, low altitude, and the tool is inflexible. Get weather in San Francisco in Fahrenheit can only do one thing. Too general, high altitude, and the agent doesn't know when to use it. Get information about something is useless. The optimal altitude is in the middle. Get current weather for any location in specified units. Specific enough to be useful, flexible enough to be reusable. Examples are the fastest way for agents to learn tool usage. Provide multiple example invocations covering common use cases and edge cases. Show the input, show the output. Example 1. Get weather in Celsius. Input Tokyo Celsius. Output 18 degrees, partly cloudy. Example 2. Get weather in Fahrenheit. Input New York Fahrenheit. Output 72 degrees, sunny. These examples accelerate learning and reduce trial and error. Testing tools with actual agents reveals usability issues that developers miss. Run your tools through real agent interactions. Where does the agent choose the wrong tool? Where does it pass incorrect parameters? Where does it misinterpret results? This feedback loop is essential. Tools that work perfectly in unit tests often fail in production because the description was ambiguous to the AI, even if it seemed clear to humans. Two-phase visualization. Phase 1, initial view, showing compact skill index with 10+ skill cards, each showing just name and one-line description. Context meter showing 5% usage. Phase 2, on-demand load, showing single expanded skill with full documentation, schemas, examples. Context meters showing 25% usage for that one skill. Efficiency comparison showing scalability, clean layered information architecture, 16:9 widescreen aspect ratio, landscape orientation. Each skill is packaged as a directory containing a skill.md file, the interface that's always loaded, plus supporting resources like detailed documentation, schemas, and examples that are loaded only when needed. The skill.md contains the skill name, a brief description, and when to use it. Everything else is deferred until the agent needs it. This is information architecture for AI. The benefits compound at scale. An enterprise with 500 tools can expose all of them to agents without context overload. The agent sees a compact index of capabilities. When the user asks about currency conversion, the agent identifies the relevant skill, loads its full documentation, and executes with full context. Tools that aren't needed never consume context. This is how you build capability-rich agents that stay focused. Let's see successful implementation. A legal research firm built a tool ecosystem for their document analysis agents. Each tool has a precise schema with JSON validation. Descriptions answer all 4 questions: what, when, inputs, outputs. Structured errors guide the agent when things go wrong. Semantic search enables tool discovery from natural language queries. The result? Agents that handle complex legal research workflows without human intervention. Common pitfalls destroy tool usability. Ambiguous schemas with vague parameter descriptions. Poor error messages that prevent self-correction. No examples to guide usage. Wrong semantic altitude, too specific or too general. Hard-coded tool lists that don't scale. Non-composable tools with incompatible formats. Context overload from loading everything up front. No versioning, so updates break existing agents. Each pitfall has a systematic solution. Your implementation checklist. For every tool, design a clear JSON schema with precise parameter descriptions. Implement structured error handling with actionable suggestions. Write comprehensive descriptions answering what, when, inputs, outputs. Provide multiple examples covering common cases. Test with actual agents to find usability issues. Version your tools and maintain backward compatibility. For your platform, build a tool registry with semantic search. Adopt progressive disclosure for scalability. Here's the bottom line. Tools are the agent's user interface. The quality of your tools determines the quality of your agent's actions. Precise schemas prevent parameter errors. Clear descriptions enable correct tool selection. Structured errors enable self-correction. Semantic search enables discovery at scale. Progressive disclosure enables capability-rich agents. This is Skill 8, the interface design discipline for the age of agents. If this deep dive into tool engineering gave you practical insights, please hit that subscribe button. We're building the most comprehensive education on agentic AI strategy available. Free, practical, and grounded in real engineering experience. Every subscriber helps us reach more developers and architects who need to understand these critical design principles. Join the community and stay current with every video in the series. Like this video if it helped you think differently about tool design. Every like signals that practical engineering content deserves distribution. Your engagement helps this reach development teams building agent capabilities, architects designing tool ecosystems, and engineers who need to understand why their agents keep choosing the wrong tools. One click from you might prevent a production incident at someone else's organization. Ring that notification bell so you never miss the next video. Tool engineering practices evolve, new patterns emerge, and the standards keep advancing. Notifications ensure you stay ahead of the curve, learning new skills as they become critical. We're building something comprehensive here, a complete education in building AI systems that work reliably. Remember, your agent is only as good as the tools it can use. Ambiguous descriptions cause wrong selections. Missing examples cause parameter errors. Cryptic errors prevent self-correction. But well-engineered tools enable agents to perform complex tasks with minimal errors and maximum autonomy. Design your tools like you're designing a user interface, because you are. That's tool engineering. Skill 8 in the 9 skills framework. Here's the bottom line. Your tools are the user interface for your agents. Get them right, and your agents become reliable partners. Get them wrong, and you're one ambiguous description away from a production incident. If this helped you think differently about how you design tool interfaces, hit that subscribe button. We're building the most comprehensive education on agentic AI available. Next up, we will continue with another of the 9 essential skills. Don't miss it.